So yesterday we went over the names of all the steps. We then talked about sort of a definition or what happens during each part of the scientific method. So today we'll start talking about some examples and sort of like your homework. Tonight you'll read some examples of experiments, have to answer a few questions about them. So let's start off with an example having to do with mice. Okay. So let's start with a mouse example. So in the problem step, this is when we ask a question. This is when we're trying to figure out what we want to be studying. So let's say the question that we would like to ask is, do mice gain weight if they are given extra vitamin C in their diet? Is that a question you could answer with an experiment? Yeah. You look for another copy of the second door down right there. All right. So what might be some research, background information you might have to gather before you can actually do this experiment? Sophia?
The weight of the mouse before you start.
Okay, the starting weight of the mice. Okay. That sort of would be part of setting up our experiment. What about some other things? Dave?
You could have two mice and the extra vitamin C in one of their food.
Well, you're getting a little ahead of us right now. We're going to get there in a minute. But just some background info. Olympia?
See how much vitamin C they usually get?
Okay, like what is the typical amount of vitamin C in a mouse's diet? Some other things. Jake?
Around the normal weight of a mice.
What's the normal weight for a full-grown mouse?
To make sure like some people have this thing where if they eat a lot, they don't gain weight.
Okay.
Make sure the mice don't have that.
Okay. So make sure the mice are like healthy. Maybe learn how to take care of mice. What kind of food, what kind of living conditions do you need to give them? Where there are some sources of vitamin C that you might be able to use. All that stuff sort of falls under this research step. You know, it's not really part of your experiment yet. It's just sort of some things you're going to need to know and able to set up and conduct this experiment. So we're asking the question, do mice gain weight if given extra vitamin C? What would be a possible hypothesis for this experiment? So what did we say a hypothesis is? Don't give me your 5th grade definition. Give me our new 9th grade definition. Maya?
Prediction.
About? What is the prediction about? Is it about the weather outside? Olivia?
What you think will happen in the experiment.
Yeah, it's your prediction about what's going to happen in the experiment. What would your prediction be? What would your hypothesis be if you were going to do this experiment? It's okay if you're not correct. Mitchell?
That they do gain more
Okay.
weight.
That would be a fine hypothesis that mice do gain more weight if they are given extra vitamin C. Now let's phrase this hypothesis in this way. If mice are given extra vitamin C, then they will weigh more. We often might put our hypothesis in this if-then format. Okay? If I change this thing, then this will happen. That's a good way to set up a hypothesis. Would you be able to test that hypothesis in a good experiment? Yeah. Who could give me like an overview? How would we actually do it? Quiet?
You would probably should get some mice.
Probably.
Put them in their natural environment
Okay. That's it. Would that work as an experiment to test that hypothesis? So I get some mice, put them in, so their natural habitat, so I put them in a dumpster. or in a field. I guess, is that a rat or a mouse? That's a mouse? That looks like a rat. But really we're talking about mice. So I take some mice. Let's say I put them in a cage. And then I give them vitamin C. Would I measure anything?
Yes. You would have. Oh, we have to measure. If we get 2 of the
Well,
same.
hold on. We're going with Wyatt's experiment.
Oh.
So I give them extra vitamin C in their diet. Maybe I have vitamin C drops that I add to their food. And then I would have to collect some data, right? What would I measure? Their weight. And let's say I find that their weight increased. So is my hypothesis correct?
Yes.
Is there any problem with that experiment?
Equal amount.
Equal? Okay, I would have to give equal amounts of, what do you mean equal amounts? So I only have 1 container of mice. Okay, so I give them the same amount of food. Do I still have a problem? We're missing something there. Mitchell?
They're in the same container, so they might eat each other's food.
Okay. Yeah, so let's adjust this a little bit. Okay, let's try to make this a little bit better experiment. William?
Before you said that, I was gonna say they might also keep the weight from when they ate the last time.
Okay. I'm thinking a little bit different experiment though. Setting it up a little differently. Sage?
You could get 2 mice about the same size, one cage and another, and feed one of them. Feed them both the same amount of food and get one of them out of the same.
Is that a better experiment?
Yeah.
Yeah. Because in the first experiment, I wouldn't really know. Well, maybe they would have grown larger without the vitamin C. But I didn't have that set up to actually test that. So, yeah, if we had 2 groups of mice, okay, say each that I have a mouse in each cage, they get the same food, but one gets vitamin C. Okay? What if, with 1 mouse in each cage, would that be a good experiment? Could I improve upon the experiment? What if one was just some weirdo mouse that was exposed to some gamma radiation before the experiment and happened to be growing larger? Is there a way I could improve upon that? Olympia?
Put a couple mice in each.
A couple mice in each cage? Would that be better? Would be even better. Sophia? Okay. Yeah. What if I had 3 mice? Would that be better than 2?
Yeah.
What if I had 100 mice? Which is going to give me a more reliable data? How about 1,000?
Yeah.
So as you increase the number of samples in an experiment, you're able to trust your data more and more. Because if it was, like we said, just 1 mouse or 2 mice in each cage, well, they could just happen to be larger or smaller, or quicker growing, slower growing. But if I had 100 cages of mice on each side, well then, those outliers, we might call them, those fast-growing mice or slow-growing mice, won't have as big of an impact on our experiment. So yeah, but you guys are basically right now in this experiment. So we would have 2 groups of mice, 1 group getting normal amount of vitamin C in their diet, the other getting double the vitamin C or triple or 10 times. Everything else, well, what do we do to all the other variables? Keep them the same. Same water, same species of mouse, same size cage, same bedding material. I would try to keep all of those other variables as close to the same as possible. And then I make some observations. In this experiment, what am I going to observe? What is the data I would collect? Caitlin?
The weight of the mice?
Yeah, I'd measure the weight of the mice. Maybe I'd measure it every day or every once a week or at the end of the experiment. There's lots of ways I can do it. So let's say after 2 weeks, I measure the weight of the mice, and the vitamin C mice weigh the same as the non-vitamin C mice. I would be then ready to make a conclusion from this experiment. What would your conclusion be if that's what your observations showed? Max?
It's mice don't gain more weight if they're given extra dependency?
Yeah, we would say my hypothesis was rejected. The data does not support my hypothesis. Is it okay? Yes, I still learned something from the experiment. So it's still a valuable experiment. So that's an example of how we use these steps in the scientific method. Do you guys ever use the scientific method? You do? Yeah. Who uses the scientific method? Nobody? Max, you? When?
I used it in science. I used it in science class last year.
Okay. Do you ever use it in your everyday life? Yes? I hear yeses and nos. Who says yes, you do? Nobody saying anything? Yeah? All right, well, let's say if I'm going to play this video game here. All right. So I'm playing this game here on my controller. Okay? You guys know what this game is?
Yeah.
All right. So, as I am playing the game, I might do some experiments about what do I need to do with this? Anyone play this game?
Yeah.
Okay, so if I hit the tail, what is that in the scientific method? No, what did I say? I should hit the tail as a yes. Did I test it? What are the observations? Yes. Did it work? All right. So I'm gonna again. Let's watch and see what happens. All right. All right. How about next? I'm gonna have another hypothesis. Get it again. All right. Observation. All right. Well, that didn't work. Conclusion: that hypothesis did not work. Then I have another hypothesis. I can't get it. I can't reach it. I'm trying. Is there any other hypothesis? Oh, go the other way? All right. Almost, almost. Observation? All right. All right. That's a hypothesis. Observation? All right, pretty fast. Uh-oh, cut it off. So, do you use the scientific method in your everyday life?
Yeah.
But do you label it as that?
No.
Well, you might not think about, well, here I'm going to make this hypothesis. Maybe I'm going to then make an observation, conclusion, but you actually do it. If you're baking something, you change your recipe slightly, okay? And then you bake it and you see whether or not your cupcakes are better. You strike the soccer ball in a slightly different way and see how that affects the flight of the ball, okay? If you practice on your trumpet and you change the shape of your lips as you're playing the trumpet, you're experimenting. You don't lay out all the steps like that, but that's really what we're doing as we sort of do things through trial and error. So we do use the scientific method all the time. All right. We need to go even deeper, though, into the scientific method and start talking about something called variables. You guys ever heard of these words before up there?
Yeah.
Oh, you do? So you know what they all mean?
Yeah.
Okay. So variables are basically things in your experiment, factors in your experiment that you can measure and maybe change. And we have 3 types of variables. Independent variables, dependent variables, and variables that we hold constant. Does anyone know what an independent variable is in an experiment? Yeah, it's the thing you change. How many things should you change in a good experiment? one and only one at a time. The independent variable is the one thing that you change. I tell students if they have trouble remembering, the I in independent, it looks like a 1. Because it's the one factor in your experiment you change. So in the mouse experiment, what was the independent variable in that experiment? Right? Yeah, the amount of vitamin C I was giving them. I changed that. Some mice were getting a lot of vitamin C, some were getting the regular amount. That was the independent variable. It's the thing you're testing. The variables held constant are all those other factors, the things we try to keep the same. So in our mouse experiment, what are some examples of variables we would want to hold constant? Sophia? Yeah, the same type of animal, same type of mouse. What else? There's lots of things we could probably think of that we would want to keep the same in this experiment. 7?
The cage.
The type of cage. Sage?
The type of food.
The type of food they're getting, the amount of food, the amount of water, the age of the mice. We could go on with a huge list. We're trying to make sure all those things are the same so that our two groups are as close to the same as possible except for what? The independent variable, except for that amount of vitamin C. And then we have what we call the dependent variable. The dependent variable or variables are the data you're collecting, the information you're going to gather that's going to allow you to make your conclusion. I tell students if they have trouble remembering the D for dependent goes with D for the data that you collect. In our mouse experiment, what data would we be collecting? Hey? Yeah, the weight of the mice. We measure it. We don't know it until the experiment's sort of over. Or until the experiment's going along, we start collecting this data. Do you remember that experiment we talked about on a couple days ago with the plants? That was in our notes? All right. Who could tell me what was the independent variable in that experiment, the one with the plants? Caitlin? Let's be a little more specific. So the color of the light. Yeah, the color of the light is what was different. What was the dependent variable in that experiment that we talked about? The dependent variable. Ed? The height of the plant. What were some of the variables you had to hold constant once we fixed that experiment? The amount of water. What? The temperature. What?
The type of plant.
Type of plant. Yeah, we try to keep all those things the same. We also have multiple groups in an experiment. Okay? And this is where what we talked about earlier when we said setting up this experiment, we need two groups of mice. We can't just have one cage of mice and they all get extra vitamin C because it gives us nothing to use as a comparison. We have to have two groups to set up a good experiment. We call those groups the experimental group and the control group. In our mouse experiment, which is the control group? You may not have heard of this, but you could probably figure it out. What is a control group?
A group that you don't do an experiment on.
Yeah, you basically let them be sort of normal. You don't change their conditions at all. And so the experimental group, what's that? Olivia?
The group you're testing your hypothesis on.
Yeah, the group you're testing, you change something. You're altering something about that group, and that's your experimental group. experimental group has the independent variable change and the control group doesn't. We need that control group for comparison. Just keep it under sort of typical normal conditions. So let's just finish up here talking about our hypothesis. So we've already described what a hypothesis is. It's your prediction. It has to be testable. It's your testable explanation about what will happen in your experiment. So it's not necessary, but it's often helpful to write your hypothesis as an if-then statement. For example, if I turn on all the lights, then you'll fall asleep faster. That's a hypothesis to be tested. If you only eat fast food, then you will gain weight. So in order to have a good hypothesis, it should be testable, and it has to be a statement of prediction. It can never be a question. So look at those examples. If you turn out all the lights, you will fall asleep faster. What's the independent variable if I were to do that experiment, testing that hypothesis? Jake?
The lights?
Whether the lights are on or off. What would be the dependent variable? And that is, if I were to do that experiment. Devin?
The bed.
That would be a variable held constant. Dependent variable is the data you collect.
How fast you fall asleep.
Yeah, how long it takes to fall asleep. How about another one? If you eat only fast food, then you'll gain weight. What's the independent variable in that experiment? Yeah, what type of food you're eating? And the dependent variable? Sage?
How much weight you gain.
Yeah. Are you noticing a pattern? What is found in the if part? The independent variable. And what's found in the then? The dependent variable. All right. If plants receive fertilizer, then they will grow larger. Circle the independent variable in that sentence, in that hypothesis. Underline the dependent variable in that hypothesis. Fertilizer is the independent variable. The growth of the plant is the dependent variable. If I put fenders on a bike, they'll keep the rider cleaner. Do you guys know what fenders are? Those things that like go over the tire so the mud doesn't splash up on your back. So what's the independent variable in this example? Next.
Fenders.
Yeah, whether or not the bike has fenders, and the dependent variable, Eddie?
Keeping the rider cleaner.
Yeah, how clean the rider is. All right, does this make sense? I don't need to go through every example, right? But if I did, that's what we did. Could this be a good problem to investigate?
Yeah.
Okay. Think about this experiment. Okay, so first of all, what I giving you in that? Which step of the scientific method? That's the problem. That's the question being asked. Okay. What's some research you might want to do before you actually can set up this experiment? Caitlin?
If sawdust will hurt people,
Make sure that sawdust is not going to, poison people. That would be good. Make sure it's not toxic. What other research might we want to do? Kevin?
find out how to get sawdust.
Okay, where can you get sawdust? I think that you need to know that.
How are we going to get the sawdust in the
Yeah, how do you get it into the Rice Krispie treats? All right, that's the research. What would your hypothesis be? How much sawdust could you put in a Rice Krispie treat before people notice? Olympia?
Wait, it was things on Rice Krispies?
Yeah, it does. Let's go on a percentage. What percent of the Rice Krispie treat can be sawdust before someone notices? What do you think, Olympia? 20%? How many? Anyone think higher? Anyone think lower? Okay, interesting. All right, so that's a hypothesis. How would we do this experiment? Imagine I want to set up this experiment and conduct it in Mr. Arcuri's class. How would I go about and actually do this? Danielle?
So you would get 2 Rice Krispie treats,
Okay.
and you would put sawdust on one and leave one same, and then have people eat it and see which one you think is sawdust.
Okay.
Or if they like,
If they what? Said they liked it or not?
yeah, like if that's the one that has sawdust in it, they say
Okay.
no.
Could I set this up with more than 2 groups? What would I do? Baltazar?
So like you can put different percentages of Rice Krispie treats, like sawdust and Rice Krispie treats to different people.
Okay.
So you could like have one person and like another person.
Okay, so maybe I have like 5 batches of Rice Krispie treats I make with varying amounts of sawdust and feed them to Mr. Arcuri's students and see if what?
Can you do that?
No. And see if they notice.
You should do that.
What would a control group be in this experiment? What would a control group be? Mitchell?
The group that eats regular Rice Krispie treats.
Yeah, I would make a batch of regular Rice Krispie treats. What are the experimental groups then? Jack?
The ones that have sawdust in them?
Yeah, all the others that have the varying amounts of sawdust. Okay. What's the independent variable of this experiment? Independent variable. Okay?
Amount of sawdust in each batch.
Yeah, the amount of sawdust I put in. What's the dependent variable in this experiment? Faith?
The sawdust.
The amount of sawdust was the independent variable. What data am I collecting that's going to help me figure out if my hypothesis was right? Yeah, what people's taste or impression of what they're eating. What would be some variables I would want to hold constant if I were actually going to do this experiment? Jake?
The Rice Krispies themselves.
The Rice Krispies themselves?
The way you put the sawdust in,
Okay.
the amount of sawdust you put on.
Well, that's going to be different, right? That's the independent because I'm going to have different amounts of sawdust.
The same recipe for.
Same recipe, same amount of butter, marshmallow, and whatever goes in Rice Krispie treat. Okay, good. So it sounds like you guys got this. No problem. So in our notes, there are a million examples of experiments. We're not going to go through all of them. We'll skip most of them. But your homework is going to be examining some experiments, answering some questions about them.